All right, ladies and gents, welcome back. We're going to finish up our discussion on mutations by just kind of going through a few examples. So if you take a look, so here we have this original DNA strand. We're going to work through transcription. What does that DNA then translate into in terms of an mRNA transcript, and then how do we go and produce the original amino acid strand, and then same thing with the mutation that has occurred. So if I take a look, here's my original strand. Remember, to go from DNA to mRNA, I need the complementary sequence. So A would become a U would become A, G would become C, so on and so forth. And so that original mRNA strand should look something like this. Right. Then we need to take that original mRNA strand and come over here to your codon chart and actually translate it. So remember, when we look at this, here's that first base, so that goes across these original rows. So if I'm starting with a U, that means I'm somewhere up here in this top row. And then my columns from there tell me my second base. So U, and my second base in this case is an A. So now I know I'm somewhere in this box right here. And there's my C, so my first amino acid is that tyrosine. GGC, so down here, I've got a G, a second G tells me I'm in this box, GGC, here's that GLY or glycine. So my original amino acid sequence looks like this. Now I have a mutation that happens. So I'm going to now take that mutated strand, do the same thing, transcribe it into my messenger RNA following those complementary basing rules. So my sequence looks something like this, and then go ahead and take that mRNA and use that codon chart to figure out my amino acid strand. And so here's what I end up with. And so if I come back looking at the original DNA strand to the mutated strand, hopefully you took notice that I've got a substitution mutation that ends up being caused, specifically a missense mutation. So if you look, here's this C. In my mutated strand, it became a G. All right, so originally this codon coded for a GYL or a glycine. As a result, I now have an arginine or an ARG. So single base got swapped, so that's where that substitution piece comes from. But that swap then does also result in the change in an amino acid sequence, hence, more specifically, it's a missense mutation. Let's take a look at this one. So here's my original DNA strand. If I go through my base pairing rules, there becomes my mRNA strand, use my codon chart, and there's my amino acid. Take a look at the mutated strand. There's the mutated mRNA strand, the mutated amino acid strand, and if we dig into this, hopefully you've noticed that there's this extra base hanging out, meaning that something had to have gotten added. It got shifted, it's an insertion, and specifically we ended up adding this T here. So you should have had this line of 3 C's. Instead, in that third codon, I had 2 C's, this extra T, which now pushed this C to become part of that fourth codon, and now I've got this extra T hanging out here that doesn't end up coding for anything. So when I look, my his, my pro, my glyce didn't change, but now instead of having a stop codon, I've got a histidine, and now then it would depend on what would happen beyond the rest of the sequence that we're not seeing here. Here's another example. Take a couple seconds, pause the video, try walking yourself through this one yourself. Once you do it, come back and see if you came up with the right answer. All right, so if we take a look, there's my original DNA strand, my corresponding mRNA strand, and the original amino acid strand. Come down to the mutated strand, and now there is my mRNA mutated version, and as a result, the mutated amino acid strand. And this one happens to be yet another silent or substitution mutation. I ended up swapping that T for an A, but take a look, it's now occurring in that third base of the codon, and so as a result, if I look, I haven't changed the amino acid strand. All right, and so this one ends up being an example of a silent mutation. Here's another example. So take a second again, pause the video, try this one out yourself, see if you can get the correct answer, and then come back and check your answers. All right, so welcome back. So there's your original DNA strand, original mRNA, original amino acid sequence. If I take a look, there's my mutated strand, my mutated amino acids, and as a result, this one's a frame shift, it's a deletion, and if you look, all right, here you've got these extra two bases hanging out here, so hopefully that gave you some indication that we were shifting this reading frame, and in fact, that A there got deleted, so it's no longer here, so C shifted over, this T from this codon shifted over, leaving that G and C kind of hanging out there at the end. And in this case, this one caused a premature stop codon in the process. So not only is it a frame shift and a deletion, but then it also produces a premature stop codon, which is a nonsense mutation on top of it.